Thank you very much, Bright, and thanks everyone for making time to join our session today. This is a quick outline of the key things we are coming to talk about today from the introduction and assumptions. Bright has already touched on some of the assumptions. We'll also look at basic data commands, then data exploration and management, data analysis, and then we'll conclude. So as part of the assumptions and things to note, we assume that you've installed Stata, and then we've also assumed that you know how to acquire the demographic and health survey data set. If you don't know this, we have a video on that. Please look at our YouTube channel for that video, and then you can see how you can acquire the DHS data set, or you can just search for Measure DHS, their website, and you can read more about how to acquire the demographic and health survey data set. And then as part of that as well, we also assume that you have basic understanding of the demographic and health survey record files. We did a training on that as well. So you can also watch our YouTube channel to look at that video, or you can still read more about this from the Measure DHS website as well. And we must also say that this is just an introduction, and we expect you to learn more on your own to get more conversant with the things we are going to introduce you to. And most of these training sessions will be on our YouTube channel. And like Bright said, we are all still learning. So if there's something that we discussed today that you feel there's an easier or an alternative way of doing it, at least you can draw attention to it, and we'll be more than happy to also learn from that. Now let's go to Stata to practice some of these things we've talked about. Okay, so today I'm going to do this with Bright, and as and when the need arises for him to join or for him to clarify something, he's more than happy to do that. And we'll be using more of our do file. Most of the things that we are going to discuss, we'll use the do file to explain that, which will make available to you as and when it is ready. So just bear with us. And our screens are a bit smaller, so just bear with us as we alternate from the do file to the Stata interface. I'm going to put myself somewhere here. Then let's see. Okay, yeah, I think this way should be fine. All right, so to start with, we are going to look at some basic Stata commands. And as I'm working in a do file, I believe if you want to follow through this session, you can also just go to your Stata and then open a do file. And to do that, you can open that from your Stata interface up here, where you see do file editor. You can just click on it. So for instance, my own, if I click on it like this, I'll see a do file editor open. Or you can also type in your command window, do edit, and you can get your do file open for us to do it together. And another thing I want to also say is that forget about the green lines. The green lines are just our notes or things that we want to take notes of. So forget about those ones as we do the training or practice some of these things together. So now that we are about to start, the first thing we need to do is to use the clear all command. And this is important because we can clear the entire data set within our Stata memory. So mostly we assume that the Stata software has saved some previous files that we're already working on. So to start afresh, you can use the clear all command. So to do that, we are going to use these commands, those with the blue and then black. those ones are the specific commands. And then the green ones are our notes. So we can highlight this here and then just execute it here. So if we use the clear all command, you can see that there's nothing in our stata interface, which is very good. The next thing we want to also talk to you about is the set more of command. And the set more of command tells Stata to run our commands continuously without worrying about the capacity of the results window to display the results. There are instances, some of the commands we are going to execute will get a very long output, which might not fit in the results window. So in that case, if you don't set more off, then it will truncate. It will not continue. Or you have to click on more before you can see the other parts of the results. So to avoid that, you just have to set more off. And I'm going to do that also now. And there are two things. You can just look at the command and then also type it in your stata command interface. Set more off like this. Or you can, if you are working from the do file, you can just type it. And then there are two ways to execute. Either you click by the line numbers and then go to execute. In some of the especially window, you will see execute, but here, yeah, okay, here is also execute. That is fine. So you just do this, and then the command runs nicely for you. The next thing we also want to draw your attention to is the set max var command. And then the set max var, what it does is that you are telling the software to set itself to occupy the maximum number of variables that it can contain. And currently, the software contains about 32,700 variables. So that is the maximum number of variables that it can contain. I think it's slightly more, but this was just to ensure that you know the variables or the maximum number of variables that it contains. And you can do that either temporarily or permanently. So maybe if you prefer to do that at any time you are going to use your stata, that is fine. But I always believe that if you set it permanently, that is fine. And to do that, you can use the set max var permanently command. So you can just type set max var, and this is the number of variables, the 32700, and the number of variables. This is important because most of the survey data sets, it contains a lot of variables. So if you don't set this, the system will not allow you to open the data set. All right. So if you run that command also, you see something like set max var preference recorded. So now I've set my maximum number of variables to 32,700. Now let's look at another important thing, keeping track of your work. Keeping track of your work. Already, I have opened the do file already, but the next thing I have to open is a log file. And to do that, you need to close everything just in case you have an existing log file. But if you don't have an existing log file, that is fine. But I'm assuming that we all have existing log files. And to close an existing log file, you have to use the capture log close command. Another thing I need to also draw your attention to is the fact that because data is more of command-based, always take notice of spaces and even how the letters are. So for instance, this is capture log close. I might just want to run it this way. But if I combine this, or even if I omit this one, nothing will happen because I don't have an existing log file open. It wouldn't have closed. But all that I'm trying to arrive at with this is that Stata is more of command-based, so always be very mindful of how the spaces are and then the cases, whether it's lowercase or uppercase. Those are very important. Now let's look at ways to open our data set. And here I'm going to spend a bit of time to explain. There are different ways to open your data set. There are two main ways. The first one is to click on your data file or double click on your data file for it to open. So the first one is something like this. So assuming I have a folder that contains all the data files that I am going to use for my analysis. But remember, the DHS file, there are different files in the DHS folder that you download. And like I said, be conversant with the DHS record files to know the right file that you are going to use for your analysis. And today's workshop, we are going to use the individual record file because that's what contains our variable of interest today, which is screening for breast cancer. So the first option is just to, for instance, if I want to open this one within this folder that I've created. So mostly if you download your Stata file or your Stata dataset, you can get it in a zipped file. Then after that, you have to unzip it to see all the files that are within that particular folder. After unzipping it, you'll see about either 6 or 7 different files. Then you might want to create a new folder that you are going to use for your respective analysis. And this is very important because the original file is there, but if you create a folder that you can name it how you want to name it, maybe folders for analysis or anything. But in this case, we created this folder called Data Analysis Workshop folder. And what we did was to copy the individual record file, which we are going to use for our analysis here. And then we also saved our do file in this very folder. So we are going to open the data file. So I'm going to use the first option, which is the double click. So you can see that initially I had nothing here at the name and then the label section. But because I double clicked on the data file, I've called in the data. And you can see that here, you can see use and then the path name is there. But this particular option is not really recommended because if you always want to locate your folder before you can open it, that might be a bit cumbersome. What we recommend is using the file name and then the path. So I'm going to close this and then demonstrate that as well for you to see. So we are assuming that we've created a folder that we are going to use for our respective analysis. So the second option that we can use to open the data file is to use the path name. And to use the path name, you just go to the folder where the data file is located. And then beneath that, so you can just click on the file that you want to open. And beneath that, you right click. So for instance, with my folder, if I right click here, you see open with show in enclosing folder. And please, if yours is a bit different, perhaps it's because we are using different machines with different softwares, let me see, operating system rather. So mine is a MacBook, and this is how I can locate the path name. So if I right click here, I have open with show in enclosing folder, get info, and then copy. And this is the name of the data file, GHIR8AFL.dta. And then the .dta is just an extension of a data file name. So I'm interested in copying it as a file name or path name. So I'll copy this and then I can go and put that in my do file. And to do that, we are using the cd, which is change directory command. So I'll use cd, and then I'll use inverted commas to tell the system that this is the exact path name that I want to use. Then I'll paste it here. Then I can just use this folder name. So let me execute this.
Okay, I think we have run into an error here.
Yeah.
So Abdulaziz, let me come in here.
Okay, right. Yeah, come in.
Good, thank you. So I think, like Abdulaziz explained, the best way to open your data set is to create a folder and have the data set together with your do file in there. But in order to open the data set, you need to locate the folder in which the data set is in. And that is where you use the cd, that is the change directory command. So the change directory command tells you the folder where the data set is located. And then the use command will be used to call in the data set. So I think Abdulaziz probably is
Okay,
has
okay,
gone
yeah,
a
yeah,
bit further, but I
yeah,
understand because
yeah.
I think that one is down there. So the
Yeah,
CD, that is the change directory command, tells us where the folder, where the
it's
data set is
located.
located. So now we can use the CD command, and then when we finish, we create our log file and they'll call in the data set. So you can go.
Right. Thanks, Bright, for the clarification. Yes. So that is that. But I think mine didn't run because I'm already in that folder. Okay. So assuming we have that already, then we can now come and then call in our data set. So I'm going back to my folder, and then this is the path name of the. Okay. So this is the path name of the data file, which I'm going to use. But then let's open a log file to keep track of all the commands and things that we are going to run in our workshop today. So this is the command. So you can type log using, and I'm interested in just the name of using DHS, maybe underscore training. That's the name that I want to give to the log file. And the log file, the extension for the log file is .log, .log, .log. And then I can use append. And remember, there are two ways to open a log file, either to use the append or the replace. And I'm going to explain the differences. So to use the replace, you are telling the system that whichever log file is there, or whichever previous analysis that you've run using this log file name, you are going to replace it. But if I use the append, let me run this. So now my log file is opened. My log file is opened like this. So you can see the date that the log file was opened on the 16th of March, 2024. And then the time is 6:32. If I use the append, like I said, it's going to, if assuming there was an existing log file with the same name, whichever analysis that I ran, it will continue with that one. But if I use replace here, so if I copy this one, or if I run it from my log file or do file, and I use replace, remember, it's telling me that the log file is already open. So if I want to close it, I can just use capture log close, and it closes nicely for me. So if I rather use the replace command, it will open like this. But this one, this time around, is going to replace the log file that was already existing. And I'm assuming that if you use the same name, but if you use a different name, remember, it's going to open another log file for you. So that's basically about that. Bright, do you have anything to add before we continue?
No, I think that is that.
Okay.
You can go ahead. Yes.
All right. Okay. So I think this is where I was in hurry to get to call in our data set. And to do that, like I said, there are two main ways that you can open the data set, either to click on the file for it to open, or you can use the path name to open the data set or to call in the data set. Let me use that proper word. So I'm going back to my folder to copy the path name. And to do that, I'll just click on the file name or the file. I'll click on it like this, and then I'll come here, copy as path name. So this is the first option. The first option with MacBook, if you just double click, you see the word use, and then followed by the whole path name of that particular data set. So if you want to keep that path name, you just place that in your log file. So I can place that here, or if I want, I'll use, and then I get a whole path name here that I want to use. But because I have docked this, it is truncating the file name. So you have to always be very mindful of how the file name is. But let me try and see whether it's going to open for me or not. So use. Okay, it worked. Yes, so always be mindful of getting the complete path name, just to be sure that you don't miss anything. All right, so now that we've called in our data set, we've also opened our log file to keep track of everything we are going to do. And then we also, obviously, we are working in our do file. And the do file is always very important because it helps you to keep track of all the commands that you are going to do or going to use to analyze your data. And I love keeping the do file because at the end of the day, you can show it to someone to just check whether what you've done is correct or not, or whether there are even alternative ways to do what you've done, which you will see very soon. So now that we've called in our data set, we are assuming we are going to use this DHS data set to analyze or run the analysis to achieve an objective of assessing women's uptake of breast cancer, breast cancer screening, from healthcare providers. And that variable is within this data set, but perhaps we don't know how that variable is located or how it is named in the data set. And to do that, there are different ways for you to get the variable name. One, either to use the look for command with some of the keywords that are within your variable name. So for instance, let me use the look for. And remember we said we are going to use the variable called breast cancer screening. So I'll type something like this and then search. Because my screen is small, I'm just going to be alternating. So please bear with us. So you see something like this. And there will be a lot of variables associated with some of the keywords that you are interested in, or the keywords for the name of the variable. So I searched, look for breast. And if I check here, I have breast examined for cancer by healthcare provider. So this is the variable we are interested in. So let me just see whether that is the appropriate one. And to do that, I'm going to use the free command. Yes. So it tells us that breast examined by cancer by a healthcare provider. So this is the variable that I'm interested in. So I don't really care about the other ones that are also associated with breast. They might represent different things in the data set. But before you start the formal analysis, it is always important to keep some of the variables that you are interested in. It's just a matter of choice. Other people prefer to work within the entire data set, or they might want to just keep the variables of interest. But it is always advisable to keep the original data file so that if you run into any trouble, you can go back to the original data file. That's why we're saying that it is important to keep a separate folder from the original folder that you downloaded your data in. So assuming we've kept a different file name for the file that we are going to use, and this is the original file name, which we've copied onto this, our data analysis workshop folder. And we've opened that, we've taken you through how to open that and all that. Now, the next thing is to look for the variables we are interested in to achieve our study objective. And we are going to restrict our analysis to the variables that we are interested in. And to locate the variables, you can use the look for command, or if you are already conversant with it, that you know the names of head, that is also fine. But before even settling on the variables to use as your variables within your study, it might be informed by several factors. One, so our study, we are looking at maybe breast examination for cervical cancer by a healthcare provider. So we might want to look at the factors associated with this particular variable or this particular outcome. So I'm going to be using outcome dependent, independent variables in the next set of discussions. So if you hear me use dependent variable or outcome variable, I mean the same thing. If I use independent variable, I mean the other confounders or the variables that we want to control for or we want to use as predictors in our study. So within the data set, there are different variables like you've seen, but we want to keep some key variables of interest to us. Of course, the outcome variable is paramount, which we've located already, which is V484A, which is V484A. So now that we've located our outcome variable, we can keep it somewhere. So I've labeled this here outcome variable, which is breast examination. And I use the look for command to locate it. The next thing we need to also do is to look for the other variables that we want to control for or use as predictors. And to do that, to identify predictors, one, we have to take notice of the fact that this is a secondary data analysis. They've collected the data already. So we don't really have control if the variable that we are interested to control for is not in the data set. So three key things here to note. One, the availability of the variable. Two, the interest of the variable to our analysis. And then perhaps you also know that from readings or from the literature, that variable was associated with the outcome that you are interested in, so which is literature. Or in some cases, Adam might also say theoretical and practical relevance. These things are just theoretical issues. So theoretical, and then let me use the word practical relevance to what you are doing. But this practical relevance is constrained by the availability, right? So the key thing here is the availability of the variable in your data set. All these things are fine, but if you locate them in the literature, but they are not available in your data set, there's really little you can do about it. Okay, so now we might want to control for age, we might want to control for level of education, we might want to look at marital status and all that. All those things can be found in the data set, but you can still use look for to locate the additional ones that you want to. So for instance, if I want to locate educational level or status, I can still use look for education. And then different variables names with the word education will pop up. But here we have V016, which is highest educational level. V017 is highest year of education. V133, education in single years, up to the last one, which is talking about partners level of education. But with this one, we are interested in the woman. And remember, this is the IR file or the individual record file we are using. And this contains information for women aged 15 to 49. And that is the file name or the file we are using to achieve our study objectives. So assuming we've taken the steps to identify all the key variables, but one other thing to note is that there are some important variables that are very worth mentioning. So the first one here is the V00. I'm going to tabulate that for you to see. And this V00 is the country code and face. So the country code here is GH, which is Ghana. And then the face is the 8th version of the demographic and health survey. There are different ones, but they always give it a face code. The next one is V005, which is the weighting variable. I'm sure this might be long, but let me just type that for you to see. So this is the weighting variable that they've kept in the data set. We are going to use that today in our analysis. The next one is we have the cluster variable, and then let me see here. We also have the cluster ID. So the primary sampling unit is the V021, then the strata variable, and then the stratification variable is also here. So those are the first three variables we've kept here, but they are always up here for you to easily locate them. Then the next ones are the numerous variables we want to control for, which we'll look at them in the next few minutes. But before we look at these specific variables and how we can analyze the data, I want us to look at some basic commands and functions in Stata before we move on. So the first one is the display command, which is more or less like a hand calculator. So for instance, I can, if I want to look at the display command, the command is just display. And then if I want to, let's say, subtract 745 from 1504, I can just say, okay, 1500 minus 500. I can use the display command to achieve that. So I can run that here, or mostly you might want to do that here, because sometimes it's just not a major command you are running or you want to use, but you just want to understand how the observations are. So you see that if I use the display 1500 minus 500, it gives me 100. So this more or less is like a calculator for us. The next thing we can also do is to use the command called the count command. And then the count command helps us to know the number of observations associated with a particular variable. So if, for instance, I want to use count if, we'll look at the if command also very soon, so don't worry about this. So I can use count if. Let me run that for you to see what specifically it means. So the variable V012 is age, and I'm telling the system that it should look at the sample size for those who are more than 25 years. So, or greater than 25 years. So I want to know from this data set, which is about 15,014, I want to know how many of them are aged over 25. So I can just use the count if command to know how many of the participants or the respondents are aged more than 25. I can use less than as well to know how many are less than. So I just have to change this to less than. And it tells me that it's 5,504. Then the next variable I want to also talk about is the inspect command. This variable, you might not use it very often, but it is worth noting. So the inspect command is also inspect, and then the variable that you want to inspect. So for instance, if I want to inspect age, and remember, V012 is age. So that is the respondent's current age. So if I want to inspect it, and even this one, right from typing this, I know that the minimum age is 15 and then the maximum age is 49. But assuming I don't know this and I want to use the inspect command, I can just use inspect and then the variable name. And then it tells me that the respondent's age is from 15 to 49. And then there are no missing values in there. That's about the inspect command. Then the next one, which we'll use very often in our data analysis, is the tabulate command. And the tabulate command, there are two variants of that. We have the table and then the tab. So let's look at how the table command is. So I'm still using the age variable for demonstration purposes. So if I want to use the table command to see how age is, I'll just tap tablet or table V012, and then it gives me the frequency. So take note of this. So the table gives me frequency, but if I use a tab, which is tablet, it gives me both the frequencies and then the percentage, as well as the cumulative frequency. So that is the difference between the table and then the tab. But most often you are not going to use the table, unless of course you are only interested in knowing the frequencies or the sample size. So remember, I use the count if command. So now we can know that those age 15 are about 659 in the data set, and those age 49 are about 210 in the data set. So that becomes quite informative if you want to know the sample size associated with each of the age categories. Now we can also do cross tabulations. And cross tabulation, what we mean is tabulating more than one variable to see how they are. And to do that, you just use the tab command. So now we are not using the table. To do cross tabulation, we are using the tab command. And then the tab command, for instance, if I want to tabulate these two variables, and remember, you can always run it in your do file, but because I'm demonstrating it for you to see, that's why I keep copying it onto the command window. So the variable V013, is respondents' age in 5-year age groups. And then the V102 is the type of place of residence. Is the type of place of residence. So I want to know how the age categories and then the are distributed across the different type of place of residence. So I can do cross tabulation to know how the distributions are. So let me use the tab V013, which is the age in groups, and then V102, which is the place of residence, to see how they are. So you can see that here we have age in 5-year groups and then type of place of residence, which was in two categories, urban and then rural. So about 1,335 of those aged 15 to 19 are in urban areas, and about 1,500 are in rural areas. So within age group 15 to 19, about 2,835 are within our age 15 to 19. And if we want to look at the variation across the different categories of the residence variable, we can see that. But this gives us only the frequencies. If you observe, the percentages are not there. So how can we get percentages from this particular cross tabulation? And to do that, we can use either the row and then the column, depending on which one you are interested in. So let me use the row first, and then I'll use the column second. Then I'll come back and ask you what you observe. So please take note. So the first one is this. So which gives me the age across the type of place of residence. So now we have the percentages here. That is nice. So please take note of this. I'm going to do the second one. Then I'll ask you what differences you observe. You can post that via the chat. So let me do this. I'm just going to go up a little bit for you to see. So the first one is here. This is the first one. So I used row here. And then the second one, I used column. So I'm just going to spend 30 seconds here. Then I'll spend 30 seconds in the second one. Then you tell me what differences or difference you observe. Okay. So this is the second one. So the second one, I use column. What do you observe? Feel free to unmute and then contribute, or if you want to.
Okay, so the first one that you use the row,
Yeah.
the percentages the urban and rural is up to the total in the row.
Okay.
But the one you use the column, don't you take the urban or the ruler, or you have to add everything which is up to 100.
That is very good one. Thank you. I can see Grace here. Is that
Yeah, that's great.
okay?
Ah,
That's just by the way, don't mind me. Okay, thank you for your contribution. Yes, so just like our colleague rightly clarified, so if you use the row, then you are interested in row percentages, which sometimes is advisable if you are doing cross tabulations, but it's just a matter of choice. So here, those age 15 to 19, the total within the sample or the study are 2,835. And out of that number, 47.09 are in urban areas, while 52.91, representing 1,500, are in rural areas. That is with the row. The same applies to the other categories of the age variable. But if we come to the column, now we are looking at it column-wise. So here, unlike this first one that we have the 100% here, which is this part, the 100% for the column is here, which our colleague has already clarified or explained. So if we add all the percentages here, this, that, and that, it should give us 100. So this one, we are looking at the age categorizations across these variables. So those age 15 to 19, about 18.13% of them within the age variable. So within the age variable, about 18.13% are in the urban areas are age 15 to 19. So that one, you have to trace it this way. The moment you trace it like this, you might get the reading wrong. So please take note of that as you do your cross tabulations. Let's go back to our do file, which I believe you can also see my screen. We've already talked about the difference between the frequency and then the tab. Now, let me use this also to demonstrate something. So I want to tabulate variable V013, V013, and then I'm using this same variable but with the free command. So the first one, I just use tab V013, and then the second time I use free V013. I'm coming back to you again to ask you, what difference do you observe, or what differences do you observe here? Can you see any difference? The first one I use tab, which is the tabulate command, and then the second one I use free. Okay, so the difference is that with the first one, it only gave me the age in 5-year groups without any numbers attached to it when I use the tab command. So tab V013, it came like this. But if I use the free command, I get the numbers attached to it. So what it means is that it just tells me that the first category, which is number 1, are those age 15 to 19, through to the last category, which is the 7th category. They are those age 45 to 49. This one is very useful when we get to recoding. So just take note of the difference. But if you want to constantly get the numbers or the category numbers attached to your variable, you can use what we call the num label command. Num label. So to do that, you can use tab num label, comma, add. So now if I even use tab, it's still running.
I think you have to break it because it is running for all the variables in the data set. Yeah, break the results. Okay, good.
All right. So now, if I use the num label before I use the tab V013, I now have the num labels or the labels attached to the variable in the data set, which will be very useful when we get to recoding. The next thing or the next command we want to also talk about is the summarize command. Summarize command. So the summarize just tells us that, or it gives us summary statistics. And if you just use summarize, it will give you summary statistics for all the variables in the data set. And there are quite a number of them, so I wouldn't do that. But you can summarize for specific variables, especially if the variables are numeric variables. So for instance, this one is age, respondent's current age, and it gives us the number of observations, the mean age, and then the standard deviation, and then the minimum, as well as the maximum in there. I think it's truncated, but that's what the summary or the summarize. Yeah. So this one was for the age variable. The number of observations in the data set are 15,014. The mean age or the average age in the data set is around 29. Then the standard deviation is this. The minimum age is 15, and then the maximum age is 49. Okay, if we want to see more detailed summary statistics, we can use the option detail. So let me use this again as an example, but this time around, let me take this off. So this one is summary statistics or detailed summary statistics of the age variable, percentiles, the mean, variance, skewness, ketosis, and all that. That's what the summarize variable does if you add the detail. Now let's look at some functions and expressions in Stata. These are also very important for our recoding or our data management. So we just want to draw your attention to those variables, or those, sorry, I keep mentioning variables, those functions. The first one is the addition function. So in Stata, if you see plus like this, it is addition. Subtraction is minus, which is obviously same, but multiplication is the star. So multiplication is star like this one, and then division is this. Then raised to the power is also this one. So don't worry about this. We'll definitely share the do file with you. And you may use these to create new variables. So those are the arithmetic operators. Now let's look at the relational operators. We have greater than, which is this one. We also have less than. We have greater than or equal to. There are instances you might want to know, the frequencies for those age 18 or those age 25 and above. So if you want something like this, then you have to use the greater than or equal to. Likewise, if you want to use less than or equal to, then you might want to know those who are maybe 25 or less, and you want to use the less than or equal to function. Then the other one is equal to, but Stater is funny. With this equal to, they call it strictly equal to. You have to use double equal to. If you use only one, it will not give you exactly what you are interested in. So I might want to tabulate if age or if V01 is strictly equal to 18. Let's see if that comes. Okay. Let me use this one. So I'm looking at those who are exactly 25 years and their distribution across the variable place of residence. So it tells me that about 265 are in urban areas and then 259 are in rural areas. That's what it tells me. And then we also have not equal to. The not equal to function is here. So it's this one and then equal to. So that is the not equal to function or relational operator in Stata. The next one is missing. So if a variable has no observations, it's represented by a dot. That is the missing. And then if you are going to use the recoding function, these things are very important. Or sometimes if you want to explore your data, these things are very important for you to understand. These are just a few examples. Let me quickly run them for you to see. I've already explained this one. So that's how you can use the relational operators. We also have what we call the logical operators. And this one is AND, just like ampersand, is AND. And then the bar like this, the straight bar is OR. And this one, which I touched on here, is not. So those are the logical operators as well. Let's look at an example before we now get to our DHS data exploration. So I might want to tabulate the variable. So I'm tabulating the variable if V001-012 is greater than 30, or, so this is the or V012 is greater than 25, and V025 is equal to 1. And remember V025 is type of place of residence. So I can do this combination to know how these variables are distributed across using the logical operators. Okay, so now back to our DHS data exploration. And to explore the data, you might want to use these two key things. One is the describe, and then describe gives us an idea of the nature of the variables in the data set. So the describe, let me just use this, then enter. So it gives us how, so all the variables in the data set, it gives us how they are, the names, whether it's a string variable, the variable name, and then even the variable exact name that they've given it or the label within the data set. So that's what the describe command does. Then we also have the code book. The code book, if you use a code book command, yes, already I have opened this, so it is not coming up here. But if I have not opened this already, then it will just give me the variables and then their respective observations. But if I close this, we might have to start afresh. But that's what the codebook variable or codebook function does. It tells us how the variables are and then their respective observations. Now, let's go to data manipulation. And to manipulate data, we are also going to use some of these functions or commands in Stata. The first one I want us to look at is the browse. And then the browse command opens the data editor for you to check how the data is. So you see that if I just type or run this browse command, remember I can always run it from my do file, or I can copy it onto my Stata commands window. I am doing more of that because my screen is small, so I'll keep copying them and running them here. So the browse command, this is what it does, and it gives us how the variables are. And in most cases, the numeric ones are always in black, and then those that might be string or those with specific labels are in other colors. So if we want to get an idea of all the variables and how they are here. So if you check, it starts from the first one to the last one. So the V001, which is the country code, and then the version of the survey. So GH version 8, V001 is the, I think, the age variable. Yep. Yeah. Is there through to all the specific variables within the data set. And if you check, remember we were telling you about some missing values in there. So if you want to see whether a specific variable is missing in the original data set, you can also use the browse to check. But you can also use the missing variable command or missing command in the file. But this one, you just visualize it to see how the missing variables are across, or the missing values are across the specific variables within the data set. That's what the browse command does. Now, let's look at generate. And then the generate is a variable or command that we'll be using often if we want to do recoding, or we want to change some of our variables to different forms for analysis. And the variable or the command is generate. The command is generate. The short form of that is gen. So one good thing about Stata 2 is that if you give a short form of the command, it can still run the whole thing for you. So you don't have to type the whole generate, GENERATE. You can just use the short version, which is gen. But now I want to generate a new variable called age 1, from the original age variable within the data set. So I can just use gen. So gen age 1, let me probably even give it a different name, or age_1 is equal to V012. If I want to be sure that the variable is generated, then I'll use tab of free. Remember now, instead of having age 1 here, I have used underscore. So I have to use this one. So it has generated a new variable for me called age 1. That's what the generate command does. Then from this, I can still generate this one for display purposes. We can also label our variable, the new one that we've generated. So let me go down. And in most cases, all the new variables that you create, you find them at the bottom of your data set, unless you specify that you want to see them up. So now, if you check this variable, the name is there, but the label is not there. So we might want to label it just to be sure that everything is okay within our data set. And to do that, we'll use the label command. And to do the labeling, we use the label, which is the command name, followed by variable, and then the name of the variable, the original name that is there, and then the label we want to give to that variable. So just observe, I'm going to run this. And this one, if you also use a short version of the variable, label var age1, and the inverted commas here, that is the name you want to give to your variable. The label, sorry, you want to give to your variable. If I run this, I'll still get the same. Or if I use the short version of the variable, label var, I'll still get it. So we see that now it has added the label, which is new age, to our data set. Let's look at renaming. So we've created this age1, but we might want to rename it in our data set. And to do that, we'll use the rename command, which gives the variable a new name. So we have age1. Maybe I want to change it from lowercase to uppercase. So rename the old variable name, then the new name. So let's see that works. So it has changed from the age1, which was lowercase, to capital H underscore 1. That is now, so we can still change it back using, so if I want to rename it again, so rename, I probably will just do a reverse of that. So we've brought it back to the original name. So that's what the rename command does. And then we also have the describe, which I've already indicated. Oh, yeah. So now our new name has changed. So it tells me that the variable is not found. So as you rename your variables, always take note of the name changes that you are making in the data set. And then the describe command, or the DES, tells us the storage, how the variable is stored, and then the display format. So this one, it tells us that it is a numeric variable. Okay. Now let's do a bit of cloning or changing of the variables using the same variable options or names. And to achieve that, we'll use the clone var. It's similar to generate, but you don't need to label the variable again. That's what the clone var command does. So for instance, now original variable for age in the data set is V012. And now we want to generate another variable called age or age2 using this. We don't want to change anything. We'll just use the clone var. Then the name of the variable that you are going to create, the name comes first, then equal to, and then the original variable. So I'm going to generate a new variable called age2 using the clone var command. Let me free age2. So you can see that it is the same. Nothing has changed. So with this one, I don't have to come and then do labeling. It has given me the same properties of the variable within the data set. The other thing, or the other command, is replace. Replace. But the replace command, always be very careful when you are using this, because you use this with the relational operators. But I'll leave this for now so that when we get to recoding, then I'll demonstrate that for you to see. But you can also create a new variable with an empty set. You can create a new variable with an empty set. So for instance, I want to generate age3. So generate age3, or gen, which is a short form of generate age3. is equal to missing. So remember the sample size for this is 15,014. So it has generated 15,014 missing values. Now we can just browse this to see, or if we want, we can just browse this to see how it is. So everything is missing in there. We browse only this one to see whether indeed it has created missing values. Then we might want to replace the age variable with a different variable in the data set. So for instance, now we've told the system that it should generate age 3, which is equal to missing. But we now want to replace age 3 with a variable called age 1. But remember, I have changed this. So if I run this command, it will give me a red line. So we have to change how this variable is. So maybe I might have to change it and replace it with age 1 or age underscore 1. So now the system tells me that 15,014 real changes made. So the age 3 variable that was missing, it has now replaced it with the same values for the original age variable. So I can browse this just to confirm whether the values are the same across. So you see that the first one, this is the new one, and this is the original one, assuming that is the original one in the data set. So 2020 through to the last one. That's why they replaced that. But we'll talk more about that as well when we get to the recode session. Okay. Then you can also use drop or the eliminate command, which is very also handy when you want to keep or eliminate some variables that you are not interested in. So now I've created these two variables, 1, 2, 3, 4 variables. I might just want to drop them from the data set. So I can just use drop, and then the variable name comes. Then. So I've taken it off from the data set. But always be careful not to drop variables that you are using for your exercise or analysis. And if you've accidentally dropped a variable, but you've not saved your data file, you can just clear everything and then go and recall your data, and everything will come back. So be mindful of using the drop command or in your data analysis. So that's about the drop. Now let's look at the if command. So the if command just specifies certain things we want in the data set. And I've already used this, but let me just emphasize that again. So for instance, if I use this, what I'm telling the system is that it should tabulate V00, V01 to if, and the V025 is place of residence, type of place of residence. So I want to tabulate age for only those in, one is urban, for only those in urban areas. So if you check here, the sample size for those in urban areas, we have 7362. And here the total is 7362. So that's what the if command does. I can flip it to the opposite side. Okay, so let me pause here and then we'll take a few questions. Then we'll come to the main thing, which is the recoding, because that's what you are going to do more, or as far as your DHS data analysis is concerned, you might be recoding some of the variables. So let's pause here, give ourselves a little break, ask questions if they need be, then we'll continue. So I'm going to stop sharing so that Bright can take questions.
Okay, so thank you so much, Abdulaziz. And I really understand some of these things, especially if you have not prepared your do file or if you don't have the Stata software installed. Um, Following can be difficult, but the good thing is that we are recording the session, and we would also create an opportunity for further questions after this session. If you want to talk to us via phone, or if you want us to have a one-on-one session with you, probably we can arrange a time and then go through some of these things with you, because we know that not everybody will be able to catch up whatever is going on. But I have been able to follow, and then because I have prior knowledge, maybe it will not be difficult for me, but for beginners, you might have challenges. So this is the opportunity for you to ask questions. And then once we are able to deal with the questions, we'll go ahead to do a recording, which is very, very important when you are doing this. So Millicent's hand is up. Millicent, please go ahead with your question.
All right. Good evening. Thank you so much for this section. It's really wonderful. I think I happened to miss the very first class, which is a introduction to DHS data. And then I got the second one, and then this is very great. Like I am like, wow, like it's gonna be helpful to my statistics class, which I've been struggling with. We are using that. I'm new to Stata. What I was using during my undergraduate days is SPSS. So I'm so happy. Thank you so much for all this. Then my question is the first class which you said was recorded and posted to the YouTube video, because I searched REMS consultancy on YouTube, but I couldn't find a video of the first class. So how do I get the first class? Yes, that's my question. Thank you.
Okay, thank you so much, Millicent. We have not yet posted that on our YouTube channel because the one working on it is still working on it. So what we will do is that just pardon us, give us some few days or probably a week or two. We will get all those ones uploaded together with these ones so that you would have access to the full training sessions that we are organizing. So probably it was maybe, I don't know whether you didn't get what we meant, but what specifically I mean is that it is not available. What we mean is that we are going to post it on the platform, and then we will share the link with everybody on our social media platform to have access to it. Thank you. Donatus.
Yeah, please, thank you for the opportunity. I wanted just a recap of what the clone, like, what's the purpose, the clone. I think I missed it. So,
Okay.
The
Good
clone
one.
var. Okay.
Yeah. So the clone var is similar to the generate, but with the generate, if you use the generate, you have to label the variable name if you want. But with the clone var, it's just from the word clone. You are just duplicating the variable in your data set for maybe recoding or something. In some cases, you want to keep the original variable so that if there is a mistake, you can go back to it. So the clone var is just to keep or duplicate that same variable in another form or in another name. That's what it does.
thank you.
Welcome.
Okay. Thank you, Donatus. Any more questions? Please feel free to ask questions. We are trying to give enough time for questions and answers. That is why we are paused here, so that we can clarify issues before we go on. So please feel free to ask questions.
Please, I think that for me, my issue has to do with the recoding. I didn't get that part well, but so let me ask. So with the recoding, is it that we are generating our own like variables from the already existing ones, or I really don't get the recoding bit. But since you said that we would go into details with that. I'll just wait.
Okay, yeah, thank you, Mary. Yeah, I think we just got to that point and then pause for questions. So just stay tuned. We'll demonstrate that for you to see.
Okay, sure. Because I would just like to know what's the purpose of the recode. When I recode, and what are you doing?
Okay, don't worry.
Get there.
We'll get there very soon. That's where we'll go to before we pause.
Okay,
Yeah.
sure.
Any more questions? Okay, so if there are no more questions, we assume that the rest of you have followed and you are getting everything. We know that there are some of you that have been working with the DHS for a very long time, and some of these things are not new to you. So we are happy we have been able to touch on some of these things that you already know. So we will go ahead and look at recoding. Recoding is a very, very important command in Stata. And when you are working with the DHS, you can't easily work with the DHS without using that command. That is why we paused to spend a lot of time on this one. So Abdulaziz, please go ahead and let's see what recoding does. Thank you.
No problem. And thanks, Bright. Just like we said at the beginning, we are also still learning. So some of us who are more experienced, if there's an alternative way of doing something that we've not touched on, feel free to suggest or feel free to contribute to the session. Or even if after this session, you want to get in touch with us to make inputs before we share the do file with our colleagues, that is also fine. All right, so now let's talk about recode. And this command, like Bright said, is very important when you are analyzing your DHS data set. Why? Because you will be changing some of the variables into different forms just to ensure that they are fit for purpose for your analysis. So basically what the recode does is it changes the values of numeric variables according to the rules specified. And values that do not meet any of the conditions of the rules are left unchanged unless an otherwise rule is specified. And before I proceed, let me use this opportunity to acknowledge my colleague Bright and then one of our colleagues as well, Richard. They gave me this do file for me to add on for this presentation. So I really appreciate that. So we are going to do the recoding using religion as an example. And remember, when we started, we said it is always important for you to check in your data set or have an idea of the variables that you want to use in your analysis. And remember, we said we are looking at V4, let me see, 484, which is breast examined for cancer by healthcare providers. That's what we are using for the demonstration purposes. We want to look at the factors associated with breast examination. But before that, we need to recode some of the variables and all that to get to our final analysis or clean version of our data for the analysis. And there's a variable we want to control for, assuming we want to control for religion in the data set. So religion, the variable name is V130, which I have here, but I just did this to show you that perhaps if you want to locate religion, that's how you can locate it. Or if you know it already, that is also good. And I want to see how the options are, or the response options for this variable are in the data set. So the response options, I have 1 Catholic, 2 Anglican, 3 Methodist, 4 Presbyterian, 5 Pentecostal, 6 other Christian, 7 Islam, 8 traditional/spiritual, 95 no religion, 96 other. And I might want to recategorize this to group them into like terms or similar variable options or response options. And this is one of the reasons why your contextual knowledge in terms of what you are doing is very important. We know that from 1 up to 6, they are all talking about Christianity. And then 7 is Islam or Muslim. And then 8, they are traditionalists or spiritualists. And then 7 is no religion. The other thing you need to also take notice of when you are doing your recoding is the observations for the specific outcomes of that particular variable. So here we have other only 17. So if we decide to use this with our recoding in our analysis, we might not really get precise estimates for our regression model or our modeling. So it is sometimes advisable for you to do recoding to collapse some of the categories together to get more observations to help in the getting of precise estimates for your analysis. So now that we know there are 7 okay, good point. We'll respond to that very soon. Derry? So now we want to recode this variable into, let's say, 4 categories, right? So we can see from the variable that from 1 to 6 are all talking about Christianity. 7 can stand on its own, which is Islam. And then the last ones, 8 can be also a different category. And then the last 2, which is 95 and 96, other. So to answer your question, in most cases, they have conventions in the data set or in the recoding of the variables or coding of the variables. And this is the original codes they assign to the no religion and other category within the data set. So you just have to know that this is how the variable or the variable option for religion are. And then in your recoding, you need to take notice of all those things. So they are captured like that in the original data file.
And
Unless, Bright, you want to add something
let
to
me
that.
add something.
Yeah.
So, in addition to what Abdulaziz has said, Derry, in the DHS, sometimes the categories differ per the country. So when you go to another country, you may not have only Catholic, Anglican, Methodist, and all that for Christianity. There will be other categories of Christianity in there. That is why the numbers don't follow. So they have created a space so that if there is any other category apart from those that we have here, they can make room for that. That is why the no religion and the other have been given codes that are wide apart in order to cater for that as well. So I think in addition to the fact that they are standard codes assigned to these ones, sometimes because there could be other religions, they have created this for those other religions to fit in. So when you take the data set of another country, you may find the categories more than what we have here.
Good points, Bright. And to also add to that, the recoding sometimes is also very important if you want to do multi-country analysis, like Bright indicated. So maybe within the geographical scope that you want to consider for your study, you are considering religion variable. And there are different categorizations for religion. And you need to recode them to similar categories to aid in the merging of the data files for your analysis. All right, so to do recoding, you first of all need to look at the original response options, which I use the most welcome, Donatus, which I use the free command. You can also use tabulate if you use the num label add. But if you don't use the num label add, then you can use the free command. But some of us, the free command might not work. So if you try that and it's not working, you can try this SSC install free, and you follow some of the processes to download. So it's an add-on command to download it. It might not be in your original package. So if you don't find that, then please use SSC install, or you can use find it free. Then let me see. It might open up something like this for you to follow to install the add-on command. Back to our recoding. So now we want to recode 1 to 6 as Christians, and then 7 as Muslims through to the last one. And to do that, we just use the command recode. So recode followed by the variable name, and then we open bracket. We open bracket, then 1 to 6. So the options for the respective responses for the religion variable are here. So we have 1 up to 6. So we are saying 1 through to 6. This one, we can use 1, 2, 3, 4, 5, and 6. So 1 space, 2 space, 3 space, 4 space, 5 space, through to the last. Okay, very good point, Mary. I'll come to that. So through to the last one, which is 6. But if we want to save time, Stata still accepts this 1 through to 6 as 1. And the 1 here is our first option that we want to create for the variable. The first option, which is 1 representing Christians. So to give the label to the option 1, we use inverted commas and then the name. Then we'll close our bracket. So our first bracket is for Christians. Then the second bracket, we'll open another bracket. And then remember, the second one is 7. So 7, we are telling the system that 7 is now equal to 2. It's just a matter of choice. You can decide to start from 0 or 1 through to the last one. But we started from 1. So 7 is equal to 2, which is Muslims or Islam. But remember, we are calling the first category Christians. So we can call this one Muslims. Then the third one is traditionalist or spiritualist. So which is the 8th option here. So we are telling the system that 8 should also be equal to 3. Yeah, we are giving it the name traditionalist. I've demonstrated something here with the 3 bars. This is a command that was quite lengthy, and because my screen is small, I wanted to break it so that you can see if I dock my screens. So if you write a command that is very long, and if you want to break it, so this one, I can still continue from here, but I can take this out. Then I'll run it as just a single command. But because my screen is small, I just want you to see the code, and then if I run the specific command, the output that comes. So that's why I did it. So this one, we call it breaking a command. So this, although it's on a different line, but because I've used these 3 lines to separate it, if you highlight everything together and run, you can still achieve the same purpose. Then the next thing is to specify. So you close our bracket for the last option, which is 95, 96, which is no religion or other. So we are combining these 2 categories as well. And the reason why we are combining it is the other categories, they are small. No religion is also quite small. So we are not wrong to say other. All those who do not fit into the first specified categories, they can fit into our other category. Then we can, so I want to copy this here and then run so that. Then the next thing is to use the gen command. So here you can either use gen or into. Then bracket open the new variable that we are creating. What name are we giving to it? We are calling it religion. We can say religion recoded or religion recategorized. It's just a matter of choice. But we are calling it religion. So I have this here. And then I've run it like this. So it tells me that 1, 3, 3, 4, 5 differences between V130 and religion. So some of the options were basically similar, but it tells us that now they've created these differences. And for us to be very sure, okay, so I kept it in bracket because that is now the new variable that I am creating. So I use the function gen and then into bracket the new name of the variable that I'm creating, religion. That is why I kept it into bracket. Yeah. So I might want to see how the new variable is. So I can use the free command or the tabulate command. So let me use the tabulate first before I come to free. So now, so I have Christians, Muslims, traditionalists, no religion or other. But let me use the free command. So the free command now gives me the specific numbers that are attached to the response option. So now our 1 is Christians, 2 is Muslims, 3 traditionalists, 4 no religion or other. So that's the new variable that we have created. So let's look at the last part of, so like I said, all the new variables that you create, they always come to the bottom of your data set. So we have religion, which is recode of V130, which was into bracket religion. So it tells us that we have recoded this variable. But we might want to label this instead of keeping the recode of V130. If you want to keep it that way, that is okay. But if you want to label it, remember how we labeled variables when we were doing the previous session. We'll just use the label var, or we can just shorten this label var religion, and then the new name religion recoded. So let's see what happens. So now the name has changed from recode of this to religion recoded. Now let's practice another recoding using age.
Okay.
And this is the original age variable. There's another version of this which is into 5-year age groups. There's this one, but assuming we are not interested in 5-year age groups, but we want to put it into different age groups, we can recode this original variable to achieve, the V012, to achieve the new categorization. So as we are going to be developing our surveys or analyzing data sets, how we categorize variables are also important. There should be a basis or reason why we are classifying them into the new categories that we are going to use. But if we want to group this into 5-year age groups for demonstration purposes, we can follow a similar strategy. So we'll recode V012, the minimum age, which was 15 through to 19, which we can still type 15, 16 in that order. But to save time, we can just say 15 through to 19 is equal to 1. That is our first category. And we are naming it 15 to 19. Then our second category is 20 to 25. And please, when you are recoding, always ensure that there are no overlaps. The moment there's an overlap, you are going to mess up your new variable. So 15 to 19 for our first category. The second category is 20 through 25, which is 2. and we are giving that name 20 to 24. In that order through to the last one, which is 45 to 49. And we are naming it age_cat. So let me run this as well. So let me free age cat. I want to see whether the categorization was done well or not. So let me compare this with the original 5-year age group variable. So the first one, we have 2835. Our first one is also 2835. The second, 3139. Second, 2224. Okay. So if you check here, what do you observe here? What do you observe? The 20 to 24. I wanted to demonstrate the overlaps that I'm talking about, or being meticulous in your recording. So here we have 15 to 19. My second one was 20 to 25, right? And then the third one was 25 to 29. Do you get what I'm saying? So now our options are not the same as we have in the original data set. Is that clear to us? So it is always very important for us to, okay, Bright, be taking the questions,
Yes. I've
taking note
noted
of,
the questions.
okay, yes, so that, yeah. So this was just to demonstrate that when you are doing your recoding, you need to be very, very mindful of the categories and their response options to ensure that you achieve what you want to achieve. But assuming we now want to group the age groups into 10 categories, but we are not labeling it from the start. So we can recode our original variable, which is recode V012, 15 to 19 is equal to 1, the first category, 20 to 29 is second, 30 to 39 is third, 40 to 49 is fourth. Then instead of the gen, we can also use into. Then we run it like this. We can use the free command. So here, let me add this note before I forget.
So I think the first one, there is an overlap. Or yes, for demonstration purpose, we kept the overlap, so we have to change it, the 20 to 25.
Yeah, sure. So we'll add that note here just for members to take note when they are doing their recording.
Okay.
Yeah. The second one, we've now created a variable age _10 into 10-year age groups. So if you tabulate it or we use the free command, you can see that we only have 1 to 4, but we don't have the labels around it, right? So if we want to do the labeling for this, then we use the label command. So we are now going to tell the system that it should label define age _10. 1 is equal to those less than 20, right? So 15 to 19, or we can still call them 15 to 19, but just for the matter of demonstration purposes. And then the second one, 20 to 29, the third one, 30 to 39, and the fourth one, 40 to 49. So let's see whether this will work for us or not. So now we have that. So let's now label var age10 _ this. So now we have the labels attached to it. because we've now labeled it, and we told the system that it should label the variable age 10, age underscore 10, with the label definitions that we specified up here. So now we have the labels for our variable, but previously it was just like this, which you wouldn't know which category represents what. Okay. Then there's another way to generate it, but for time purposes, I'll stop with that one, and then we'll add it to the do file for you. There's also the extensions to generate, which is called the egen command. The egen command. That one is an extension of the generate command. It creates a new variable of the optionally specified storage type, and then the equal to is given function based on argument of a function. And remember, we're talking about arguments or the functions previously. So if I want to, let's say, generate a variable called the sum or the total of the age, I can just say egen age sum is equal to total of the variable age. Let's see whether that works or not. So free the age sum. So you see that it has summarized all the ages within the data set for me using the age variable. So we have a summary or the total of the age variable. And then we can also egen is the same way, which will give us that. Okay, so now let's look at the DHS data analysis itself. Assuming we've done all our recodings, we've specified our outcome variable, which is the breast examination. And then we've specified everything in our do file nicely. All that we need to do is to now maybe highlight or run them line by line. So let me do this. So this is our first variable. So that is breast test. That is our outcome variable. And then the recoding, this is just another option that you can use to recode. So, and the new variable that you recode, you can also use the label var command to relabel it, which I've demonstrated already. So the explanatory variables that we have in our data set, we are now going to look at those ones one after the other. And I intentionally labeled them from one to the last one, which is the 13th variable. So our independent variables are 13.